Hey, how's everybody doing? Today we're going to explain a second order linear homogeneous differential equation with a constant coefficient and what it means, and also the different type of cases you could solve it with. Well, first of all, we have to define each term. Well, that's the general form of the whole equation. And how do we know it's a second order? Well, you see the highest prime in the equation, which is 2. That's how I would know it's y2 right here. That's how I would know it's a second order equation. Okay, then how is it linear? Well, you see the coefficient. It's the my bad. The prime, the variables are multiplying by constants. That's how I would know it's a linear. Well, if it's another variable, it's not going to be linear. How do I know it's a homogeneous? Homogeneous. That's how you pronounce it, I guess. Well, homogeneous means the whole equation equals to 0. So instead of the dx, it have to be 0 over here to be a homogeneous differential equation. Okay. Well, with a constant coefficient, so it have to be a constant in front. To we can't have variables with the primes, or that also wouldn't be linear too. Okay, let's start with the first equation here. We have this one should be really simple: double y prime minus 3y prime minus 10y equal to 0. That's how it's homogeneous. And you see, we're not multiplying by variables. That's how it's not non-linear and both constant with the constant coefficient. Okay, to make it to a quadratic equation or simplify it in that kind of term, we first have to find the characteristic equation, which is I guess it's the same thing, just trying to sound cool. Well, just bring in everything. What's the first thing we have here is just y prime, brought that right here, r squared minus 3y prime minus 3r minus 10. It's kind of like taking an integration or derivative. That's how it looks to me, but hey, and we have to equal it to 0 to be homogeneous. Well, this is a simple equation where I didn't even have to do the quadratic equation. I just factored it. When you factor this, you get r, well, that's what you get, r minus 5 times r plus 2 equal to 0. And we just set that to the other side. Now we know that r equals negative 2 and 5. Okay, the general solution for this problem is going to be, I chose the variable y of t just because. And we have c1 e to the power of rt, and that's c is just a representation of a constant. That's the equation right here, but c is just a representation of a constant, c1 and c2. So the first equation here is c1. We plug in the r right here, and for c2 we plug in the other r right here. So that's the general solution for this equation. You see, C1 and C1 e to the power of negative 2t plus C2 e to the power of 5t. And we get this general solution, and that just tells us the roots we have are they're real roots, but they're not repeated solutions. We don't have the same roots. Now we're going to see another example that what is a double solution. See, we got y prime minus 6, my bad, double y prime minus 6y prime plus 9y equal to 0. We do, again, we find the characteristic equation. This is going to be equal to r squared, just bring that, the double y prime, 6r, and plus 9. And that's supposed to be equal to 0. If we equal that to 0, square root, factor it, we're going to have a double root. It's going to be the same thing, r minus 3, So just to make sure it's recorded, we have to put R equal 3 repeated. That's how we know which case it is. Since you see that's the actual equation here, we put it C1 minus C1e to the power of 3t. But since it's repeated, we add another c. So it's going to be C2t. We have to add a t because it's repeated. E to the power of 3 to the power of 3t. That's how the general solution of it looks like. Now we're going to get to more complicated things like complex. See, this is an equation y double prime minus ty plus t plus 2y equals 0. And this equation is going to be a little harder because we can't factor it. See, when I bring the characteristic equation here. So we have to use the quadratic equation. And in that case, you see, that's my SAT calculations right here. I just plugged in everything. And here, I got a negative number. Square root of a negative number, you get an I. So it's 2 plus or minus 2I over 2. And that's just going to leave us with 1 plus or minus I. Well, if you end up with a plus bi equation, a plus or minus bi, to be exact, equation, our general solution going to have this form. C1e, well, it's kind of, I kind of multiplied it to look like this, but that's the main point. It's going to be C1e to the power of at cosine bt plus C2 et e to the power of at sine bt. You're just going to have a cosine and a sine. That with a C1, we're going to have a cosine. With a C2, we're going to have a sine. And we just plug in the information we already have. So because we already have 1 right here, that's for A, and for B, since, well, it's an I, but we always know there's a 1 over here, the coefficient of B, or what B is in this equation, which is also 1. So see, I plugged in 1 for A, B, A, and B, and that's the general solution for this equation also. Hope you learned something.